How's it going, folks? This will be the last section for the packet, April 23rd to May 10th? May 8th? Something like that. So this will be on similar polygons. We looked at all those ratios for a good reason. We're going to be using more ratios. Check the skills up here. So we're going to look at, we need to use congruent sides. That's something we'll need. And we'll also need to know how to solve each proportion. In this section we'll learn about similar polygons, a similarity ratio, a golden rectangle, and the golden ratio. Those are nice little tidbits of mathematics. Let's start out with objective 1, similar polygons. Two figures that have the same shape but not necessarily the same size are similar, and that's where they use that little squiggly line, or a tilde in Spanish. Two polygons are similar if 1. Corresponding angles are congruent, so that means all the angles are the same for one polygon as they are with the other. And 2. Corresponding sides are proportional, so that means not necessarily the same length, but if you have one polygon has a base of 5 and the other polygon has a base of 10, and then the first polygon's height is 5 and the second polygon's height is 10, it's a 5 to 10 ratio on each, so they are proportional. The ratio of the lengths of corresponding sides is the similarity ratio. So for that example I just gave you, 5 to 10, that's a 1 to 2. That would be the similarity ratio. So let's look at our first example here, example 1. So let's look at, we're going to draw a polygon here. ABCD is congruent to EFGH. And so let's draw this polygon. There's 2 here. Our first one, A, B, C, D, at 53 degrees. And then we have the smaller one, E, F, G, H. E, F, G, H. This will be 127 degrees. Okay, recall that parallelograms have same side interior angles, so there are 2 corners on each side, so like split it into 2 sides, the left and the right. The left side, those 2 corners will add up to 180, and on the right they'll add up to 180, so 53 plus 127 is 180. So let's look at some things here that we're going to answer. Measure of angle E is equal to what? Okay, so these are similar polygons. That means their corresponding angles are congruent. So E is going to correspond to A. Okay, because it is most similar to it, for 1. 2, if I just took this polygon and I laid it inside the other one, the edges, these edges would line up here perfectly. Okay, that's one way. If this were rotated, you could rotate it so that those edges are going to meet up, and you'll have what we call a corresponding angle, and so that needs to be the same there. So measure of angle E is equal to measure of angle A, and so the measure of angle E is 53 degrees. That's because corresponding angles are congruent. And then B, so the ratio of AB to EF, so let's look at that. AB to EF is equal to AD to EH. Okay, so if AB is AB over EF, so that's like a ratio. We're looking at property number 2, corresponding sides are proportional. So if AB is proportional to EF, that means that AD must be proportional to its corresponding side, which would be EH. So So this is property 2, corresponding sides. Sides are proportional. Okay, so let's look at, we're going to do another example. And with this one, we'll actually throw some numbers in there for the corresponding sides. So we want to determine whether the triangles are similar. If they are, write a similarity statement and give the similarity ratio. So here's our triangles. This is ABC with sides 15, 12, and 18. And then we have a slightly bigger triangle. D, E, F. With sides 16, 20, and 24. Okay. So we want to determine if these are similar. So what do we need to do? The first one is we need to determine if corresponding angles are congruent. So you remember these little marks here? These markings? They mean that they are, if I have one mark and one mark, that means that they are congruent or the same. So F corresponds with A. Measure of F corresponds with measure of A. Measure of B corresponds with the measure of E. And then the measure of C corresponds with the measure of D. Okay. So that said, let's redraw this bottom one so that it's in the same orientation. Okay. As the top one. That way we don't have any confusion as to which sides are corresponding to each other. Okay. So I've redrawn it. So right now, because all the angles, all the corresponding angles are congruent, I've knocked out qualification 1, corresponding angles must be congruent. So 1 is taken care of. I'll call this 1 up here, and I'll call this 2. Now number 2, we must know if corresponding sides are also congruent. Or sorry, proportional, not congruent, proportional. So let's do FE. FE is this side. Its corresponding side would be AB. And so that's going to be 20 over 15. I'll do EA. EA is here. We'll put that over BC. That's 16 over 12. And then FD over AC. That's 24 over 18. Now, if all of these reduce to the same thing, then all the sides are proportional. Meaning that Well, let's reduce it first. So 20 over 15 is the same as 4/3. How did I do that? I took out a 5. 16 over 12 is 4/3. How did I do that? I took out a 4. 24 over 18 is 4/3. How did I do that? I took out a 6. So since they're all the same, all sides are proportional, and the similarity ratio is, let's write this with the smaller number first. So it's a 3 to 4. So that means that this one here, this small triangle, this would be your 3, and this large one would be your 4. Okay, so every side on this triangle is 3 units to every 4 units of the larger triangle. It's like if you're baking, right? And you want to upscale your recipe by half a portion. Okay, so if you're doing 1 portion, it says do 1 cup. If you want to increase that by half a portion, you need to add another half cup, right? So that's a 1 to 1.5. If we want whole numbers, I just need to multiply that by 2. So multiply each number by 2, the 1 and the 1.5. So I'm looking at a 2 to 3 ratio. 2 cups for the 1 portion, or sorry, no, we've multiplied by 2, okay, so we multiply each cup. So the original portion would be 2 cups, the larger portion would be 3 cups. So it's a 1 to 1, it's a 2 to 3 ratio. So this is a 3 to 4 ratio. For every 3 cups here, I have 4 cups for this large triangle. Since every side is 3 to 4, 15 to 20, 12 to 16, 18 to 24, since every side is 3 to 4, we've knocked out the second qualification for similar polygons, that corresponding sides are proportional, and we found the similarity ratio of 3 to 4. Woo! Okay, let's go over one more example. So you can use proportions to find unknown lengths in similar polygons. So this is example 3, which will be using similar figures. Okay, so we have LMNO is proportional to QRST. So here's our first one. These are trapezoids. Good, they're in the same orientation. I always think it's really annoying when they draw them in different orientations. That way you have to redraw them. So we have element O. This is 5. This is 3.2. This is 2. And then we have X up here. And we have 6 down here. Okay, so we know that, and we want to find the value of X. Find X. We know that our trapezoids here are proportional. So there's going to be a similarity ratio. And with that previous example, I did every single side because I didn't know if they were proportional, so I was just confirming it. I know that they are proportional, that's a given, so I can just say that the ratio here is a 5 to 6. Okay, so the base here is 5, the base here is 6. That's our ratio we're dealing with, 5 to 6. Okay, and we want to find out what X is. So remember the last section, we can write it as 5:6, or we can write it like this. 5 over 6. 5 over 6 is equal to 2 over x, x being the one we want to find out. So 5 to 6 is equal to 2 to x. At this point, we just cross multiply. Okay, so have 5x equals 12. Divide by 5, divide by 5. X equals 2.4. So x is going to be equal to 2.4. Okay, there's different ways you could have done this. Playing around with the calculator in this instance, I would say it's helpful. You kind of learn inventive methods for solving. So go ahead and try it out. The way to check your answer in your calculator, plug in 5 over 6, whatever you end up getting for x, whatever you end up getting for this answer, 2 over that answer must be the same as 5 over 6. So whatever the decimal is, 5 over 6 I think is about 0.83333. This must equal 0.8333. If it's so, then you're good. You found the correct answer. If it's wrong, scratch it, try it again, try a new invented method. Alright guys, stay tuned for the next video. See ya.